Welcome back to the channel. Today's video is going to be about fuses and breakers. This is a small little 30 amp panel. I've got two of them, and I also have a breaker panel down here. I'm going to explain to you what I've learned over the years about the differences between a breaker and a fuse, what the benefits of a breaker are and what the benefits of a fuse are, and the different locations where I actually use them. And where would somebody actually have a need for these type of electrical panels? Now this one here is a 30 amp and it's a fused breaker panel or a fused fuse panel, depending on which version you get. I'll show you both versions. And this particular style here is by far going extinct because most places, depending on where you are in the world, don't allow the glass fuses that screw in anymore. It's hard to even find them. I bought two of these panels for $10 each. I don't use them for, I would say, most situations that some people would. I'm using them more for off-grid uses with power inverters and generators. So I actually prefer this style better than the breaker. We'll get into it right now. I'll show you the differences between them both. And let me know in the comments below whether you've ever hooked one of these up yourself and whether you prefer fuses, the glass fuses that screw in, or the modern flip breaker. So let's get to it right now. Okay, so let's start off right here. This is a breaker panel right here. This is a 60 amp breaker panel, and it looks quite different than this one. This one here is a disconnect panel, and I'll explain how that actually operates. One takes glass fuses, the other one, well, they're resettable breakers. So, and if we go over to here, we're going to take a look and we're going to see that there's quite a difference in fuses, and of course they even have these screw-in breakers. So this is a 15 amp breaker. It's a mini breaker that screws into here. And these are just terrific for the people who could actually use a breaker rather than having the fuse, because you know what? When a fuse blows, it goes into the garbage, right? So a little side note here. Last week's video on all these handles that you have here for your files. Well, there they go right there. So here's two that I had from last week's video. And I'll show you on the wall over here. What I've done is I replaced them all, and you know, these all had pointy ends on them, and now I've got them all done. And I'll put a link down below if you want to know how to do this to your hand files, because you know what, when a file is finished, well, you throw it in the garbage, right? Well, these handles, they go right with them, and they last a lifetime, and these are far better off than them other cheesy things that we had before. But let's get back to the differences between the glass fuse panel and a breaker panel. So let's start off with taking the cover off. Let's take a look underneath and let's see what's going on in there. Well, let's start off right here. This particular panel here is a quick disconnect panel as well. If we just move these fuses out of the way and I cycle, you could see the arms down here. Well, that makes contact. There, it's contact. There, it's disengaged. So that way there, before you even open up the panel, you can, you see here, you can put a lock on here if you wanted to as well. Before you even open it up, you can turn the power off, where the other side, the breaker panel I have, doesn't have that feature. So now let's just take a look at the fuses. This is a 15 amp fuse. This is a 30 amp fuse. This particular panel has a maximum capacity of 30 amps. And when you see them two brass bars go up and down, that's what the whole panel is rated for the disconnect and the connection of this rated amperage, which is 30 amps. So this is rated for 120 volts or 240 volts, maximum 30 amps. This one here is a 30 amp fuse. You notice the difference? It's got these extra legs on the outside here going all the way around. This one doesn't. So a lot of panels that you see still exist in today, you could screw a 15 amp into a 15 amp socket. But if you tried to screw this one in, them legs would prevent it because it would never be able to reach the center point to make contact for a connection. So this particular panel doesn't have the obstructions in the bottom because it allows a 30 amp fuse. So you have to actually think about that when you're thinking about getting some either a breaker or a fuse panel. I prefer the fuses myself in certain situations, and one of them is that the benefits is lower cost. These panels here are so cheap right now because really there's not much demand for them, so you can get these panels, you know, for very, very cheap, and the fuses are relatively cheap compared to a breaker. Now, the main idea behind a fuse, well, when they first came out, the biggest problem they have with a fuse is it cannot be tested. Once you bring it up to its specific capacity, well, it blows. Then you got to take the fuse, throw it in the garbage, and get another one and replace it. And that's what the advent of breakers came in, where they were resettable. So the main benefit is lower upfront costs. And when you think about it, how many times do you reset anything anyways? I mean, you got breakers in your house right now most likely, and how many times have you had to reset your breakers over the years? And the same with fuses. The only thing is they've gone with breakers because, well, they can be tested, and each one can be tested at the factory, and it will trip, and it's resettable. So there's, you know, and there's a whole bunch of technology that goes into breakers that you can't get with a fuse. But for my situation where I use them for off-grid purposes, now I don't use these for DC, but when you're talking amperage, amperage is the same on AC and DC. It's measured differently, but amperage is amperage. There's no difference on the voltage. No matter what the voltage is, amperage is still the same. If you got 2 amps on DC, it's 2 amps on AC. The conversion is a bit different, but it's still measured 2 amps. And the biggest thing that I would say that people have a problem with and they struggle with is they look at this and they say, this is a 30 amp fuse, right? And they think that this fuse protects their lines from amperage, which it doesn't. This has no idea how to measure amperage. And if you take a look at a breaker, it has no idea how to measure amperage either. This one here is 15 amps, and it has no way of measuring amperage. The only thing it does is it's got a small little strip. I know it's going to be difficult to see, but there's a small little strip inside there. And when this particular circuit goes above a rated temperature, and the rated temperature correlates to roughly the amperage. So when you're thinking about this is going to shut off at, say, 30 amps, well, that is not actually correct. This will shut off when this gets high enough in heat that it'll break that tab inside there. And the testing is done with the proper cabling coming into your panel, the proper cabling going out, and the proper use of the machinery matched to the particular amperage draw that you need. So take, for instance, you got a 15 amp fuse here, and it does not blow at 15 amps. It blows when the temperature of the conductors that feed the circuit on either side come up to a temperature range that will break this bimetal tab inside. So if you are up in the Arctic and it is -50, you can push this 15 amp fuse quite a long way past 15 amps because it is so cold outside. Compared to somebody who's living in the desert, the sun's beating down on this panel, well, you're not going to get the same capacity of amperage out of the panel because of the heat. And the fuses are all operated off of heat, not amperage. Now, the factory likes to make these as close as they can to the amperage rating, but if we just take a look here at, we just take a look at the back of a package here. And if you take a look at the back of a packaging, you're going to see that this particular one here, now there's different types of fuses, and this one here is the 30 amp, but this is a D type. Now there's all kinds of different types. There's a P type just for your like regular electrical lighting. This is a P type, which is delayed fuse. And if you take a look at the packaging there, I don't know if you can read it or not, but it will actually overload of 200% for a maximum of 12 seconds. So this will go 200% above the 30 amp rating for a maximum of 12 seconds. In my experience, I don't get breakers that have that same adjustability and that flexibility. For most homeowners, you're never going to have to worry about that. You know, as long as you make sure you're not plugging in stuff that is rated higher than what your fuse capacity is, you should be fine. And so where would somebody use a panel like this? Take, for instance, if you wanted to hook up a welder in your shop, even a 110 volt welder. When I had my 110 volt welder, I would pop a breaker all the time, all day long. You would blow a 15 amp fuse all day long. The machine was not rated for 15 amps. It was rated for 20 amps. Now this is a 30 amp panel, so I could put a 20 amp in here and it would run all day long, no problem. The thing is, when you're operating a welder and you just happen to ground out your tip while you're welding a bit, well, the voltage spikes like you wouldn't believe. Or I've seen people that will get a welder and put like a 40-foot extension cord on it that it's not designed for, and you get excess voltage drop, and as your voltage drops, your amperage rises. So if you got a 15 amp breaker or a 15 amp fuse, you're just going to be tripping it all the time. And that's where I like the fuse idea, because I can put a 30 amp in here if I'm using, take for instance, my Milwaukee chop saw. It's a steel chop saw and it runs about 23 amps. So a 20 amp is not quite good. You can get a 25 amp, which would be a better idea than a 30. Get it as close to what you can. But that thing will spike up to about 23, even 24 amps if you really bear down on it. And if you tried to run it off of a 15 amp breaker or a 15 amp fuse, it just pops it all day long. So let's go over to the breaker itself, and I'll tell you the advantage of the breaker and why in some situation the breaker is the way to go. So here is a 60 amp breaker panel, and you can see I've got a 20 amp here, a 15, a 20, and a 15. Now, a 60 amp panel, you'd figure 15, 30, 45, 60, right? But I've got some 20s in here, and I'm going to be using this for a project where I'm not going to be using all of these circuits at the same time, all the time anyways. And if you take a look at your panel in your house, well, you're never going to use all the circuits that are in there at the same time. So, you know, for me, this is just fine. So, I mean, that is the whole idea behind a breaker, is it's resettable. You can turn it off, you can turn it on. You don't need to have the disconnect handle on the side. If you want to break the circuit, all you have to do is just shut them all off. And, you know, you want to turn them back on, you turn them back on. And that's the main idea. But you're not going to be paying $6 for each one of these. You're going to be paying a lot more. And if you want to go and buy some really cheesy aftermarket breakers, well, do yourself a favor and don't buy them. Get a good brand name And don't cheap out on the breakers. And I don't think I've ever seen any cheesy fuses, glass fuses. They're all pretty good brand name. I think they're so regulated that you can't even get a cheesy one, but I have seen some really cheesy aftermarket breakers. I'd stay away from them, get the brand names. Now, the breaker is hooked up exactly the same as a fuse, and all you're doing is you're just isolating one part of the line to disconnect it. And in most instances, this type of system using a breaker is just fine. But as you can see, there's no adjustability in anything. You just can't take it out and say one day you want to put in a 30, or there is no adjustability at all. Plus the upfront expense is a lot more. So in this particular situation like this is a situation where I would install this for a set of circuits that is like, put the cover back on, and just forget it, right? I mean, that's what it's like. It's all sealed up. You got 4 fasteners. It's all sealed up, and you're done with it. And from the outside, well, you can turn your breakers off and on if needed. But I'll tell you something. How many of you go down, in your basement, and you're constantly having to reset your breakers? Because if you are, there's something wrong with either the breaker or the line that has attachment to the breaker or the fuse itself. So I mean, you shouldn't be having to go and turn your breakers, and reset them to turn them back on, because you're either overloading your system or you have a bad breaker. Now, breakers can also be incorporated into a lot of different electrical advantages for lightning strikes, high moisture areas. There's all kinds of fancy breakers out there that you cannot get with the adjustability of the old-fashioned fuse. So I mean, there's some huge benefits in safety over a breaker compared to a fuse. And the breaker itself is the same as a fuse. It does not operate off of amperage. It operates off of heat, and the heat that's generated. Now, I have used my welder in the middle of the winter time, run it out in the driveway, and after I'm finished using it, I seen where the extension cord had melted the snow right down to the pavement. So yes, you do get a lot of heat buildup, and that's the whole idea behind the protection services of a wire. And this is trying to protect the wire, the integrity, and you have to make sure that you match your breaker size to your panel, to your electrical load. And there's all kinds of theoretical basis that goes into the maximum capacity of a line compared to the breaker size. They don't want anybody running their wiring system, say at 20 amps constantly, or even at 15 amps. It's not designed to be running at 100%. From what I've read, most are designed for around a maximum of 80% capacity. So the whole idea is not to have your wiring run to the max all the time, because you do run into systems where you start up loads that go higher than the rating, and then as soon as the internal temperature here gets too hot, well, it just shuts off. So that's pretty much the idea behind the difference between a fuse, low cost. This is much higher cost. I would say this here has more safety devices built into it than this. This can't be tested at the factory. This can. So they can test each one of these to make sure that it shuts off when it gets up to a certain temperature, and it will match very close to the specifications of the amperage of each one of the breakers, which I think is far superior than the fuse. But for low upfront costs, the fuse is the way to go. Plus you got the adjustability of taking one fuse out, putting in another, as long as you know what you're doing. And this is the main thing. You just can't be screwing in a whole bunch of fuses that are higher capacity than what the wiring that you have attached to them. So there's a little more to the subject than just a a little bit of knowledge, because like they say, a little bit of knowledge is probably more dangerous than not having any at all. So I would say do yourself a favor, read up on it, read the electrical codes, read how the balancing of a circuit compared to other circuits. Know how you're actually doing what you're doing before you attempt it. And I recommend everybody see a licensed electrician when you're doing any wiring at all. All my wiring that I do is, like I said, off-grid and used in conjunction with generators and power inverters. Well, thank you very much for joining me here today. A little bit of a demonstration on the difference between fuses and breakers. And I just like to say, if you like in the future, you're going to see me hook these up in different projects. I've got projects planned for like way out in the future, and you're going to see these be incorporated, and you'll get a better idea of the reasoning behind why these little panels are just terrific. And the fuse panel itself, the 60 amp, you're going to probably pay with them breakers about $125 to $150. Like I say, I paid $10 each for these with $6 fuses, and you get two for $6, not one. So thanks for joining me here today. If you haven't seen this channel, you're welcome to subscribe and follow along in the future on my endeavors. And this is going to be all up in Northern Ontario. Until then, cheers.